for the next awesome session from Daniel Paul, Staff Developer Advocate. He's going to be walking you through the methodology and principles of data modeling for MongoDB. So if you're new to MongoDB, if you've already worked with MongoDB, these are not just tips and tricks, it's the principles of. So please enjoy, please give him a warm welcome and your attention, and thank you very much. And Q&A will be after, so have your questions queued up.
Hi everyone, I'm Daniel Coupal. I've been at MongoDB for 10.5 years. Over that period, I had different jobs. I currently help our strategic account customers with their data models. This is the best job ever. My team and I work with many banks. A lot of our big customers are banks, as a matter of fact. So interestingly enough, they offer very similar services, as you may guess. Therefore, they have a lot of similar applications. These applications are subject to the same regulations, at least in the United States. One example is the Bank Secrecy Act. This is some of the text of the act. Obviously, I'm not going to have you read this, especially after lunch. In simpler words, what we have here, it means that financial institutions are required to assist the US government in detecting and preventing money laundering. Why am I saying that? It's because we're going to use this example for one of the applications that we see in many of the banks. So it basically translates to many banks building applications to track transactions. So let's imagine such application for this presentation. We're going to call this application a transaction logger, or TL for short. No, TL may mean tough luck if you're a bad guy. The system helps you catch you and prevents you from stealing money from the good guys. But if you're a good guy, it means tender love. Okay? So the system is here to help us. As a side, let's assume the bank is asked to track its customers. If an involved party is not a customer, the bank is still required to report them, but they don't have to include as much information. So if I were to model a simple version of this system with a traditional relational database, it may look like this. We have a customer that makes one-to-many transactions. Each transaction receives or sends the money to another party that we will call a payee or a payer. So the payee is involved in one-to-many transactions. So the interesting thing about this entity relationship diagram is that if I was going to ask you to do that, each of you would come up with the same solution. Because there's only one solution that respects the third normal form. Now, if I was going to ask you to do the same for MongoDB, you may want to model it like that. We could map the tree tables to tree collections. However, this is usually wrong. We see these schemas sometimes, and it's not optimal way to design a solution in MongoDB. You could still profit from some object to organize the columns and having a sub-object for the address, for example. That gives us a bit more flexibility and clarity. Another solution could be, let's embed the payee in the transaction. If we do this, we create a sub-object, we may move all the information about the payee. This solution has one less collection. That may be good. But we can also have a different solution like this one, where we take the customer and we embed all the transactions for that given customer. By the way, this is not the right model. If you want to see a better solution, don't leave yet. The question we need to answer is, what is the best solution and how to get to it? So before we go further, I just want to talk to you about all the different talks that are related today. Obviously, you know, it's 1:15 right now, so you're listening to my talk. We had two talks that happened earlier. One was the real benefits of teaming up with MongoDB to review data model from Andrew and our customer, Wells Fargo. The thing is, the previous presentation gonna be available. Everything is getting recorded today, so you can go back to those. And then we had at 9:10, Rick Julian, who had this famous presentation where he talks about why relational database are not fit anymore for a lot of the workload we have. the cost of doing joins, and the resources that you need in order to support those workloads. So the third one is obviously my talk. And then right after this talk, our famous asset Kamsky will give you the knowledge you need in order to get your model to work correctly. One of the most important things once you create a model to make it in execution is to ensure that you have the right indexes and you can verify that you're using the indexes correctly. So our presentation is going to be about that. And finally, if you still have some interest in more data modeling stuff for the day, Graham Robinson's going to have a pop quiz, so you can walk there. And if you're doing well, you may be one of the persons who's going to walk out with a prize. OK, so our presentation right now is going to be divided into 3 sections. So we'll start with the need to model for NoSQL and MongoDB. Then I'm going to introduce a methodology to model for MongoDB. And finally, part of that methodology, there's a phase that is oriented toward applying schema design pattern, and that's exactly what you're going to do on our little TL example that we've shown earlier. So we have a lot of cover. Let's get going. So the need to model for MongoDB. We model mainly for 3 aspects. We're facing constraints. We want to identify and communicate the model across the team, and we need to create documentation. If there were no constraints, we would need to model. Think of a system intelligent enough to know what you retrieve often, retrieve together, queries that need to have a very low latency. And this AI system will define and update the model for you. Maybe we'll be there in a few years, but not there yet. But we'll probably get there at some point. The reality is we do have constraints. There are some constraints that you cannot change, like the speed of light. So hardware is bound by that. Communication networks bound by that. You have other constraints that may change, with time. Like right now, disks are so much slower than RAM, but you could imagine things changing. But these are important constraints because basically, when you're designing your schema, think about your collection. At the end, everything is like you have a physical model on there. So why do we keep things in RAM? Why do we keep things on disk? And finally, obviously, there's also a set of constraints that come from the software you're using and the OS. And those tend to change even more often. If we go back to the keynote we had this morning, there's a lot of new features that were added and a lot of, for example, improvement in performance. If you think about that, this may have an impact. If we're going to continue that road, you may model things differently because you get so much better performance. You don't have to do as many optimization in your model. Anyway, I'll come back to that a little bit later. But in short, we model to face and answer to constraints. When I run a review with our customers, I like to identify the category of models this project will fall into. I use this uncomplicated binning where I have 5 buckets. The first bucket is for a project with a lot of write operations. Things like Internet of Things, time series data are a good example of projects that fall into this category. The second bucket is when we have a ton of reads. The same thing. We want to be sure we arrange the data in a way that we don't waste resources by doing too many read operations. Usually, less joins will give you much better result and will consume less hardware. The third bucket is about reads again, but this one, the latency dominates. They're not necessarily a ton of reads, but they have to be super fast. Applications with UIs tend to fall into that category. The fourth bucket is when you have a ton of data. This poses a different set of problems. What you're really trying to do here is to reduce often the cost of storage. And the last one, and a very important one, about simplicity. So if you're not in any of the first 4 situations, the 4 buckets, the last one's about simplicity. We have a lot of customers that what they want, they don't have a ton of operation, but what they want is be able to develop the application very quickly, be able to change the code, be able to change the schema easily, and MongoDB is very good about that. A lot of applications fall into that bucket. As for communication, the process of modeling is key for the team to understand each other and reach a solution. A common methodology and vocabulary that will remove the ambiguity and helps identify the important aspects of your model. A small team obviously needs much less formality. However, a larger team, a distributed team, must have this common vocabulary. And that's going to be part of our methodology. And finally, like any methodology, what we're trying to do is get something that we can put down documents so other people in the team or future member of the team can refer to and understand. So we get things like the requirements, the ER diagram, which I like to call the document relationship diagram because it's a little bit different than what we have in the relational world. A list of collection and their important fields. And finally, a workload description. This is really important. We want to understand what are the main operations we're going to be doing on the system. So where did we leave the introduction? Yeah, so this was the diagram, the ER diagram we had for a relational model. And then we said, maybe this would be the solution with this one-to-one mapping tend to usually be very wrong. Or maybe it could be this one. And then we had the third one where everything got embedded. So which one is the best one and how do we get to it? The key principle for that is the workload determines the optimal grouping of objects into collection. So we need to understand what we're going to be doing with the data. And that principle brings us to the second section of the talk. So let's talk about the methodology to model for MongoDB and reach the solution about which model should we have. So our methodology will have 4 phases. We're going to have the requirements. Then we're going to look at the workload for application. Then once we have that, we can look at the relationships between the different pieces of data. And finally, we're going to apply patterns, and you'll see what the pattern is going to bring us. So the main thing that differentiates this methodology for creating a model for a relational database is that the data model is the first and most important part when you do the relational modeling. So thinking about the workload is a secondary concern. But with MongoDB, or with any other modern database, the workload identification is the most important aspect of the model. And this is not just because NoSQL's databases are different, but because the world has changed since the 1970s. Databases are 1,000 times bigger. Customers hit the applications by million, 24 hours a day. These applications can't afford downtime and must provide incredible performance and must be developed at lightning speed. So very different set of requirements than what we had in the past. So first phase will be to identify the main requirements for the project. So we will list what the system is supposed to accomplish. The theory and practice around writing software requirements is pretty extensive, so I'm not going to spend too much time here. But the principal thing that we want to do a little bit differently is to identify what are the main entities. Here, I really want to emphasize on the term main, because when you work with MongoDB, you should not be concerned too much with secondary or weak entities. These usually would be modeled as embedded entities inside your main entities. So going back to our example, or transaction logger, these are the entities, main entities we're going to have. So we're going to have a transaction, we're going to have a customer, and we're going to have a payee. So the second phase of our project is the identification of the workload. This is where it becomes interesting because it is an essential phase that is done differently from what we're used to do with relational databases. The main objective of this phase is to produce a list of operations describing how the data is being created, read, updated, and deleted from our database. If we work on a large project, we'll probably list more operations to ensure we get everything that could be significant for it. If it's a small project, you probably have a good feel of what's the main or the 2 main operations that you're going to be doing. So in our case here, we have few writes operation, few reads operation. We give them a name. We show a little bit the information they're going to play with. And as you can see, obviously, there's few operations at the top here that are executed much more often than the other ones. And that's often what you're going to get in practice when you do a model. One or two operations will drive most of your design. So these few operations are the one that you should spend a little bit more time on it. So you're going to dig a little bit more into them. We're going to try to understand them more, add information. So for example, 300 million writes operation per day. It's a metric that we do understand as a project stakeholder. But if you're a DBA, you probably want to see something that's a little bit more easy to measure toward the spec of your hardware. So you may want to have something that is number of operations per second, for example. Latency is a very important metric. It's obviously much more important for read operation usually than writes, especially for user interface. And the other thing we get here is, as we dig into our requirements, in this early stage, it's also the right time to make important and difficult decisions. Let's face it, we probably want to keep the data forever, but it's very costly to keep all that data. So the question we have to ask ourselves, when does it make sense to delete it or archive it? So in this case, we're going to say, hey, we'll just keep 90 days of data in the hot database, and we'll push the rest to an archive, which is going to be much cheaper. Finally, flag some additional controls that we may have to do with those operations or those entities. For example, do you need to respect something like GDPR, especially if you're in Europe? No, for this use case, obviously, the right to be forgotten is probably the last thing a customer can ask for in the system that's tracking bad actors. Okay, so in summary, we want to write down those operations, quantify them, and record all the assumptions. And the reason we're doing that is we can best act on a new requirement if something changed, only if you know what the original requirement was. Okay, so from the entities we listed in the first phase, we had a bunch of operations. Most operations seems to be like returning, querying a transaction. That's going to be our main entity that we're going to be using. Looking at the type of operation again and going back to our type of project, it seems like we're going to have a lot more write operation than anything else here. Once in a while, some search are done, but we're going to have a kind of constant stream of write operation coming in. I see a little bit of, some read operation. The data may be big, but we're going to have option to archive some of it. We already made the decision here. Now that we know what we're modeling for and should optimize for, let's start identifying the relationship and start organizing our collection and documents. So we're going to talk about the relationships. But before we do that, I want to bring a little analogy. So this is a remote control car. This is how it looks when I put it out from the toy chest. This is how it arrived when I bought it. So a bunch of pieces. As much as it was fun putting it together, now I know I can repair it. I know I could order a part that is broken. The last thing I want to do is to reassemble it every time I'm playing with it. So I want to save time. I want to just get it out of my box and start playing with it. Well, it's the same thing with MongoDB. You want to store objects the way you're going to be using them. If you have a one-to-many relationship between pieces of data, think about it. When you run that join in a relational database, you're always joining the same pieces with this one. So doing that in MongoDB, doing this repeated join doesn't make sense. It's costly, more reads operation, the cost of doing the join. Just put the information together. So basically what we're saying, and this is probably the most important rule when you're modeling with MongoDB. If you're not sure what you should do, go back to this rule. So what is used together in the application should be stored together in the database. Okay, just to be sure we're all here on the same page, I'm going to talk about referencing and embedding. So referencing a piece of data would be something like a foreign key. So if I have a person that has a driver's license, on their driver's license for that person. I'm going to have a key that points me back to a document, another document. And if I'm embedding, I'm taking the entity that is on one side, and I'm just putting it in the first one. And it's a very good practice to use a subdocument for that, so you know exactly what the entity was. So choosing between those two options is really the essence in data modeling for MongoDB. And what's interesting is, we talk about relational database or like NoSQL, non-relational, but we just show you like two different ways you can model a relationship. Well, usually in a relational database, there is one. So the non-relational doesn't really apply. Okay, so for most relationship, it will either be obvious or become obvious as you're doing more model, getting experience with time. However, there are cases, even for us, where it's not obvious and we need a little bit of help. So what we did is we created this list of questions to help you identify if it's preferable to reference or embed. For each question, you're going to circle the yes or the no. Sometimes there's no, so maybe there's nothing to circle. So let's take the relationship between a transaction and a payee. So I'm going to look at relationship between two entities, but the same apply to any piece of information. A field to another field also have a relationship that is one-to-one, one-to-many, or many-to-many. So our first question here is, would keeping the piece of information together lead to a simpler data model and code? Since we don't intend to do much with the payee side of things, let's answer yes here. Our second question is about weak entities. Weak entities are better represented as embedded, usually. Embedding them also take care of the integrity rule and cascading delete operation. We also have this question. It just doesn't apply in MongoDB. You delete the main entity, get rid of the parent, and all related weak entities that are embedded are also deleted. So back to our use case, because we don't want to keep track of a payee. If a payee is not part of any transaction, we don't have to do anything, so we'll answer yes again. And then we go on. We know every questions. I'm not going to read all of them. Upon completion of the question, if you end up with a table that looks like this one, where everything is circled in one column, in this case embed, it's pretty clear how the two pieces of information should be arranged, should be modeled. Now I say, again, two pieces of information, it doesn't have to be just the entities. But the result may not be clear-cut all the time. You may have answers in both columns, highlighting the benefits of embedding or referencing, depending on the choice you're going to make. So if we look at the example of transaction and customers, that's basically what we end up here. Now, some requirements may be so much more important than other ones. You can give higher weights. So maybe we're not just counting the number of bubbles. But in this case, it seems like it's pretty in the middle. We're not sure if we're going to embed or reference. And that brings us to our last phase. This is exactly what our last phase comes into play. The schema design patterns are defined exactly for that, optimization and alternative representations to give you maximum performance and flexibility. So the schema design patterns are organized in families. I have 5 families that go from computation, grouping, life cycle, polymorphism, and relationship. We obviously don't have time to dig into all of them. However, I'll give you additional learning reference at the end of the presentation, reading, or videos that you can go to learn more about all those patterns. But what we're going to do is we're going to look at a few of them, and we're going to apply it to our use case. One warning, I know people who are first introduced to design pattern, they sometimes are really enthusiastic, like, this is pretty cool, I can do that, can do that. But at the end, we have to remember that sometimes keeping things simple also get us a long way, especially for maintenance on the project on the long run. So only use the schema design patterns if needed. Schema don't always have to be complex. So let's apply some of these schema design patterns to our transaction logger application. So based on the previous section where we had a list of questions, it was not clear we were going to embed or not the customer inside the transaction. So we had these 2 alternative representations. If I'm going to reference, I'm going to have 2 collections or 2 documents. In the case I embed everything, then I just get a transaction where I have information about my payee and my customer. Payee is pretty clear. we embedded it into the transaction. So let's have fun, let's have some fun by adding requirements to a transaction logger to demonstrate some of these schema design pattern. I was talking to a friend and about adding like requirements, making things more complex, and they say only engineers enjoy more complex problems. And I say, yeah, that's right. But there's also some wisdom in that statement. No, sometimes we like complex solutions, and I think we should really strive to a little bit more for simplicity when possible. Anyway, so this is our first requirement: bad actors. No, yeah. Poor Sylvester, a few months ago he just won his 12 Razzie for the worst actor of the year. He has the most by far. Well, poor may not be the right term. His movies have grossed $10 billion over the years, and he has like 400 million, so it's good. No, this is more like what a bad actor look like that the bank want to track. So in this requirement, we're going to track more information about the bad actors. And we'll also link or bring some information possibly from data banks that are made available to us to be able to do the analysis. And for that, we're going to introduce our first pattern called the extended reference pattern. And this pattern is concerned by reducing the number of joins in queries. So we identify the fields using joins for the most common operation, and we copy these fields into the main document. I think you're seeing where I'm going here. The most common operation we're on transaction. Why do we want to always join to the customer in order to bring some of the fields? We're going to avoid that by bringing, so instead of just using a customer ID in my transaction that's going to point back as a foreign key to my data, I'm going to bring some of that information that I want in my transaction. Now I can do the same lookup on the transaction, or I can list a bunch of transactions without ever reading the information from the customer. If I need more information about the customer, I can click the link and I'm going to bring the information. I think you see how this pattern is a very good answer to the case where, on your questions, we didn't have all yes, all no. Sorry, one column or the other one, so we didn't know if we were going to embed a reference. In this one, by still keeping the things separate, but bringing just a little bit, just enough to not having to do all those joins, it's going to resolve the issue. Our second requirement is going to be about analytics. We want to compute different metrics on the suspected transaction, the bad actors, and we need to also compute trends over time. That's what we've been told. And for that, we're going to introduce another pattern. This one is called the computed pattern. And this pattern stores result of computations directly in the concerned document. These computations are generally done at right time or periodically. This pattern is very useful when you have a high read-to-write ratio. Without the pre-computed value, if you have a high read-to-write ratio, if you think about it, you'll always be doing the same computation at read time. I'm assembling things, I'm doing a count. So we want to save all these computation by doing it maybe when the write come in, or I'm going to have a cron job that's going to go and modify the data. So applying that to our use case, for a customer, now I can keep track of all the transaction account also of the suspected transaction, and I can also have the transaction per month. So note that when the month is over, the count don't change. So why not calculating it once, sticking it into the array, putting it there, and now I can always display all the information about this actor without having to recompute, again, the same thing over and over. So in a system that has like ton of data, and you're bound by your IOP, your read and your writes, those will make a big difference. So our next requirement, well, this is Jan Calment. She lived to be 122 years old and 164 days. She's an outlier. This is 3 years longer than any other human being. So she's going to be our poster child for the next requirement that we call long life or long data life. So to satisfy this requirement, we must keep the flag transaction for 30 years, and the same for all the transactions for a bad actor. And for this, we're going to introduce our archive pattern. So this is a very useful pattern for industries that have data retention regulations. Obviously, financial, pharmaceutical applications come to mind. The goal of this requirement is to lower costs of keeping data that's not used often. So to do so, you move the seldom reference data to a cheaper tier. It can be S3, it could be an under-provisioned cluster, because you won't care about doing a query that's going to take more time. You're really not accessing that data very often. So this pattern is easily implemented in document database, but it is very difficult in the relational database if you think about it. In the relational database, if I want to archive a piece of data, I need to archive this piece and all the other related piece that I'm doing a join. But because MongoDB lets you embed all that information, if we put everything in one document and we just archive it, you get many benefits. First, it's just one. I don't have to do any join when I want to read that document in the future. But the other thing you get is every document carries its own schema. If you're in a relational database and the schema change over those 30 years, it makes this data very difficult to read. But the document you archive a few years ago from MongoDB, it has the schema that existed at that time. You just have to make a query by customer ID and you get all the information. So what we're going to do here, there's different way you can do the archive. You can archive the document as it's because you've already prepared it to be ready for the archive. But right before archiving time, you may enhance it by adding fields, and then you'll move it somewhere else. For those of you who use MongoDB Atlas, there's something called online archive, and you can go to that functionality. You can create an archive, say which collection, which field to look at for the date, and click, and it's all done. It's going to take you about 2 minutes, and you've just created an archive physically somewhere, and the process is going to be running and it's going to be maintaining the things for you. It's extremely powerful. If you don't use Atlas, you can certainly develop the same thing and move to another cluster, S3 if you want. It's not that complicated, but there's obviously not as easy as what you get with MongoDB Atlas. Okay, and our last requirement is about new rules. For those who are fan of Dua Lipa, that's one of the songs that she released a few years ago. Or you may be a fan of Bill Maher, which is his nice section at the end of his show. And here what we're going to have is every 2 years, new regulation may be issued. So any correlation between things changing every 2 years and a new American Congress is purely fictional. So for that, we're going to bring our last pattern for this presentation, and it's called the schema versioning pattern. This is one of my favorite patterns. This is really something that we're not talking enough about when we talk about MongoDB. And the implementation from a document perspective is very easy. We're just going to add a field. You can call it version, schema version, and we're going to put that in all the documents. Now, if your document change a little bit by having 1 or 2 more fields, it doesn't justify applying that. But if you have more complex modification, this is where it's going to come. So it really makes MongoDB shine, allowing you to migrate easy schema, again, which is extremely difficult with relational database. So I'm making fun of government changing the rules, but it's the reality everywhere. Requirements change all the time, functionality, numbers, but any successful system will go through changes, likely including data model changes. So we can deny it, suffer when it happens, or we can accept it and just prepare for it. So using MongoDB as your backend database is an excellent way to minimize the impact of changes. So let's look at 2 typical types of modification. The first one is we're modifying a field. Relational database do that pretty well. Alter table, I can add something, I can change the type, whatever, works well. The other one is changing the relationship between 2 pieces of data. This is kind of pretty difficult usually in a relational database, which is interesting. Ironic that relational databases are bad at modifying relationships. Okay, so let's do this update through for our relational database. So I have a version 1 of my document. So I have people, and in those years, we had a home phone number and a work phone number. Nothing else existed. And then we have a new person who come into our database, and that person has different way to be reached. So, so Alton is this new person. So what we want to do here is we want to go from version 1 to version 2. And we're going to transfer these like one-to-one relationship between home phone and the person to a one-to-many, where we're going to be a little bit more flexible about the type of communication we can add. So now whatever new mode of communication is introduced next month, we can model it with that. So traditional updates in a relational database will look like that. On Friday evening, we're going to bring the system down. And then on Monday, we would like to have something like that. So we're going to migrate some data, create a new table, reformat things. Things go wrong, we're going to go back. Things go well, we're back online. Now let's do the same with MongoDB. I have my first 2 documents for my 2 initial chefs. And then I have this new person who's joining and like, okay, time to do something. I could decide to put them in separate collections, or I could put them in the same one. In this case, cardinality is low. What is used together should be kept together. I want to see the phone numbers all the time, so I'm going to put them there. But the magic happened here. It's as simple as that. If you have a relational database, you have a schema version for the whole schema. MongoDB, because of polymorphism, every document can have a different schema from another document. We do that all the time. This field exists in this document, it doesn't exist in this one. So every document carrying its own schema and can have a different version. We're going to use that. We're going to piggyback on that. And we're going to put the version number in the document. So Friday evening, I have my 3 documents in version 1. Monday morning, I'd like to have all my documents in version 2. Now I can go and migrate them one by one. As long as the application is able to read both shapes, I don't need downtime. Maybe a little bit degraded system because I didn't update all my queries to handle the difference in the shape, but most of it can work. And if I really want to be sure that the system's going to be fully operational, I just have to do a little bit more prep, in the app and add more stuff. But the thing is, you are in charge. You can manage this transition the way you want. You can also say, I'm going to take 10 minutes of downtime and we're going to migrate everything and be up. But you do have all those choices. So MongoDB lets you develop and deploy quickly, but also evolve your application and schema quickly. So that brings us to our conclusion. There's 3 things. I divided the presentation in 3 sections, so 3 main things I want you to walk away with. So first, the need to model. One of the principles we got out of that is the workload determines the optimal grouping of object into collection. If you're going to have a review with us, a design review, that is the first thing we're going to ask you. It's like, if you can provide your workload ahead of time, great. If you don't, that's going to be the first question we'll have in the sessions. Like, what are you trying to do? What are the rights? What are the reasons? All that. So the second principle is, again, the most important rule when you decide how you're going to embed or you're going to model relationship is what is used together in the application is stored together in the database. And finally, we saw some schema design patterns, but the most important thing to remember out of that is that MongoDB lets you develop and deploy quickly, but also evolve your application schema quickly through the schema versioning pattern. And the key thing here basically is you can start doing your schema. Things may change, you'll be able to evolve it. So you feel confident that even if you haven't made every single decision for performance stuff, you can still migrate your schema and you'll be in good shape. Okay, so to learn more, the first thing here is a book that I wrote last year. We introduced it, as a matter of fact, at MongoDB World exactly 1 year ago. It's the most up-to-date reference on all those patterns. So it's a book I co-wrote with the author of accolade and a guru in the relational world, Steve Oberman. And secondly, I talk about design reviews. We do design reviews virtually. We are doing some today. If someone is interested in having a design review, you can go to Ask the Expert and see if we still have some slots for this afternoon. But we also have, this is a .local day, we also have what we call a developer day, which is more hands-on workshop, less presentation. One of the workshops is a data model workshop. And we also do one-on-one review at that time. So we do some today, and we do some in those MongoDB Developer Day. And finally, a lot of resources were added this year. Fantastic work from the university team. First, there's a course that was already there. And I always want to talk about this one first, because there's a lot of people who come from the relational world and they feel like, oh no, I have to learn from scratch MongoDB and all that. That's not the case. You know, MongoDB is still a database. There's a lot of things that are common between MongoDB and relational database, things that you've learned over the years. So this course called MongoDB for SQL Professional is just that. We're trying to match what you know about MongoDB, about relational database, to the concept in MongoDB. The new courses we have in the university, it's a path. It's called the MongoDB Data Modeling Path. And we have 2 courses under it. We have a basic course and we have an advanced course. And if you do those 2 courses and you're doing well in them and you understand all the things, paying attention, you can try to do the certification after. So we also created a totally new data modeling certification that's just been released. And if you're doing a lot of data model for MongoDB, I will say, hey, it's a good thing to do. So again, our design review, they're there to help you to be successful. The talk from Andrew this morning will probably give much better justice of what we're doing in the reviews. But what we're trying to do is to ensure that you guys are successful. So it's a service we offer free for large customer, medium customers. Today, anyone can sign up if there's some spot. But we really want to be sure that you guys are going to be successful with your first project. We're really bullish about MongoDB. I really think this is the best database out there. But if you're successful with your first project, you're going to come and reuse MongoDB for the other project. So if we can spend just a bit of time to get you in the right direction, double check what you've done, that's great. It's great for you. It's great for us. When you use MongoDB, you develop your application faster. It costs you less money to operate them. Everyone profits from that. So that's it. There's a QR code here, but I think it's better if you go directly on the app to report your feedback for the presentation. And that's it. I still have a few minutes if there's some question.
Thank you so much to Daniel for walking us through that. If there's anyone in the crowd that has a question for Daniel right now, please raise your hand real high so I can see you. Anybody? Yes. And while I'm walking over there, the quick plug, please, 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 feedback is a gift. So thank you so much for filling out the survey.
I will move to the side right after if there's more question that I can't address right now.
So you mentioned that you could embed information directly in the document. How do you prevent data from being stale when your original document changes?
So I think the question referred to the extended reference pattern where we would embed additional information. And it's a very good question. You're creating data duplication. Data duplication, it's a no-no usually in relational database. Experience with MongoDB that, there's nothing wrong about it. So there are a few things to look at. If you bring fields that are not going to change, then you don't have a concern. So you should really select things. For example, in our transaction, what did we bring in? The name of the person, and we brought an address. Yes, the address can change. But in this case, if the address change, you may want to know the address that the person was at the time of the transaction. So sometimes data duplication may be better than no data duplication. But there are cases, yes, it's like if I update here, I'm gonna have to update few things. And there's different way you can do it. You can do it in your application. You know, this data change, I know it's duplicated, I'm gonna do it. Another way that I like is you can also listen to changes happening. Like CRC in a relational database, MongoDB have change streams. So you can open a change stream and say, whenever anything for a customer change in those fields, I know I'm gonna have to do something, and then we're gonna update the document. So at the end, it boils down to how difficult it's gonna be for me to manage this data duplication versus the benefits I'm gonna have. You know, in our relational thinking, we would just do a join and do 3 reads all the time and maybe pay 3 times the hardware all the time. In system these days that have like billion of documents and operation, the cost is so much higher. So what is my cost of implementing a little bit of code to manage it when it's needed? You know, so in this case, the one we had in the example, we wouldn't have to do much. It would be preferable to have the information copied. So I can move to the side here if there's more questions, because I think I'm done now. I see the counter down to 0. It means like get out, someone else can have a presentation. Next presentation again, it's Asia. She's been with us forever. She's amazing. And this is a brand new presentation on indexing. So really looking forward to hear it too.
Please give a really large round of applause for Daniel. Thank you